right, everybody. We're on to 4.6, second to last lesson of this unit. Again, it'll be a short one. So some functions are very difficult to integrate. There are many techniques for integration. We don't learn all of them in this class, obviously. But some are, even after you know all of them, they're still very hard. So we can approximate their value using what is known as the trapezoidal rule, or there's another rule called Simpson's rule. We are just going to focus on the trapezoidal rule for this class. And as the name implies, it is using trapezoids to approximate the area, sort of like how we used rectangles. So you have a graph A to B. If you remember what a trapezoid is, basically, that's a trapezoid. We can add in these trapezoids. All right, to approximate the area. So we're going to sum the area of the trapezoids. Well, the area is going to be the sum of the base, this bit, times the height. The thing about a trapezoid is it has two different heights. And you can look it up, but the base is just going to be delta x as it was before. And the heights are going to be the heights added together divided by 2. You can look up where that comes from. Basically, you're breaking into a rectangle and a triangle, but I don't expect you to know that. So we're going to sum this from n is equal to 1 to n, to infinity, basically, depending on what you want up here. I'll just put b, it can be anything. There's many trapezoids as you want. Obviously, the more trapezoids you use, the more accurate your picture is going to be. So we have to turn this into a formula, and there is a formula. Delta x is b minus a over n, okay? If you remember, delta x will be b minus a over n. N is the number of rectangles, right? Right. So that can be pulled out. And this is going to turn into b minus a over n. I'm going to pull this 2 out to get 2n, so b minus a over 2n. And then this h1 and this h2. If you think about it, when we're looking at this picture, for the first one, there's our first height, there's our second height. And then when you're doing the second triangle, this one gets used again, and this one gets used again. And then for the third one, this height gets used, and this one gets used. So essentially, all the heights of the trapezoids, get used twice, except for the first and the last only get used once. And we're talking about the height. So as a function, you're writing in blue, it's f of x0, which is essentially the first one, a here, plus 2 times f of x1 plus 2 f of x2 for this one and this one. All these are getting added twice in this formula. Now it's going to continue into the last one, which is f of xn, but it only has a coefficient of 1. So the only trick here to remember this formula is it's b minus a over 2n. So it's delta x over 2n, essentially, or delta x over 2. And the coefficients in front of the functions, or the heights here, it's 1, 2, 2, 2, 2, 2, until the very end where it's 1 again. So let's do an example that we know. The book uses a nice example of sine of x. We can compare our answer to the actual answer. So we're going to evaluate 0 to pi sine of x using n is equal to 4, so 4 trapezoids. All right, so sine graph, if you just remember, there's a sine graph, we're only going to pi, so we're just doing this area here. We're using 4 of them. All right, so 4 trapezoids. We're going 0 to pi, so that would be pi over 2. That would be pi over 4, and that would be 3 pi over 4. And fit it in. So we go b minus a, which are our endpoints. That's b, that's a. So pi minus 0 over 2 times number of trapezoids, 4, times f of x, 0, which is pi, to 0. That's f of 0 plus 2 f of pi over 4 is 2 f of pi over 2 plus 2 f of 3 pi over 4 plus f of pi. Coefficients at the end are 1, everything else has a coefficient of 2. And you get pi over 8 times f of 0. Our function is sine, so it's sine of 0 plus 2 sine of pi over 4 plus 2 sine of pi over 2, 2 sine 3 pi over 4 plus sine of pi. Sine of 0 is 0. You see it on the graph. Sine of pi is 0. Sine of pi over 2 is 1, so this is 2 times 1. Sine of pi over 4 of 45 degrees is root 2 over 2. So I'm going to get 2 times root 2 over 2 plus sine of 3 pi over 4 is the same thing. It's all times pi over 8. Now that cancels, that cancels, that cancels, that cancels. So I get root 2 plus root 2, which is 2 root 2 plus 2. Okay. If you punch that in your calculator, you should get approximately 1.896. Okay. Now, remember, it's an approximation. If you did this the old school way, so the integral from 0 to pi sine x dx, integral of sine is negative cosine pi, which would be negative cos pi minus negative cos 0. Cos of pi is negative 1, so it's negative of negative 1, plus cos of 0 is 1, which is 1 plus 1, which is 2. So we're close, 1.8962. It's not great, but we're close. Again, we only used 4 trapezoids. The more you use, the better you will get. All right, so that's using it on a function. Now, where it gets used a lot is in estimating areas things that don't have functions. So the classic and the one they use in the book to show us if you're evaluating a lake. So this is a bad drawing, but that's okay. So we're going to have 8, break it up into 8 sections. See if I can do this. So we're going to cut our lake off. Oh, that's okay. I can go 1, 2, 3, 4, 5, 6. Sorry, people. Probably laughing at me right now. 1, 2, 3, 4, 5, 6, 7. There we go. 8. Okay. Sorry about that. Okay. And the height here will be, let's just say 10. Let's zoom in here. 10, 20. I know these don't match, but that's okay. 25, 20, 19, 18, 17. Okay. All right. So these are our ends right here. That'll be your A and your B. I will give you one that is drawn out nicely. The width of each one of these, even though it looks different, we'll say is 10. So A has a value of 0, because it's our starting point. 10, 20, 30, 40, 50, 60, 70, 80. We have a value of 80. So if I want to know the area, we use the trapezoidal rule. So area is going to be B minus A 2n f of x 0 plus 2 f of x 1 plus f of x to the n. But I'll put, that would be b anyway. So b is 80 minus 0 over 2. How many trapezoids are there? Oh, sorry. Oh, we already give this the width. Remember, this is delta x. So I've actually done more work than I need to do. It's delta x, which is 10. Each width is 10 divided by 2. Okay? I mean, I could have gone 80 over 8, and it's going to give me 10 anyway, but delta x is 10. These are the heights, which are given to you here. So the first height at A is 0. Okay? Plus the second height is 10. Remember, it has a coefficient of 2 in front of it. So it's 2 times 10 plus 2 times 20, 2 times 25, 2 times 20, plus 2 times 19, plus 2 times 18, plus 2 times 17, and then the height at the end here is 0 as well. If you add up all those numbers and multiply it by the 5 that's on the outside, you should get 1290, and we'll say this is in meters, square meters. That is the approximate area of the lake. So when you're doing this, just to show you, I could have gone 80 minus 0, there's 8 of them. 80 over 8 is 10, so I'm going to get 10 over 2 anyway, okay? That's trapezoidal rule. If you have the questions from the book, once you do this a couple times, it makes sense. 1, 5, 35, and 39 on page 310. Email me if you have any questions. Good luck.